Hello and welcome to the solutions video for our January 27th assessments. So depending on which elements and topics you chose, there are 10 different curricular outcomes available. For the purposes of the solutions, I have each curricular outcome in its own category, so you can skip back and forth in the video as we move from one to the other. Of course, it's never a bad idea to practice the other questions you did on assess on. So, our first written response here. Write the equation of a line with a slope of -5, which passes through a given point. You can use any of the formats. There's not specified here, which means because we have the freedom of choice, I'm going to choose slope point form, because that is the most direct form. That's our y minus y1 equals m times x minus x1. So y minus y1, in this case, the y coordinate of our point is 2. Our slope is -5. The x coordinate of our point is -3. So when we subtract a -3, we end up adding 3. So here is our first equation. And that one is done. It's just straight transcription. Now, next, we want to write the equation of a line in slope-intercept form, which passes through the points 7, -8, and 5, 9. So our first step is to find our slope. Our points here . I'm going to pause a moment. It appears I don't have my writing tablet connected. All right, should be good now. Yes. All right. So our 2 points again are 7, -8, and 5, 9. So 7, sorry, I wasn't trying to zoom. I have to be very careful with hand placement because the heel of my hand can do that. Okay, so 7, -8, and 5, 9. So our slope is the change in y. 9 minus -8 is 9 plus 8. And here we have 5 minus 7. So this is a 17 over a -2. So our slope is -17 over 2. From here, we can write our equation in slope point form. -17 over 2. And I picked y is 9. Sorry, the internet seems to be slow today. I'm not sure why. And x minus 5. We were asked for the slope-intercept form. So we're going to start multiplying everything by 2 to get rid of this denominator. That gives us 2y minus 18 is a -17x, and then a -17 times a -5. We are adding 85. So 2y is a -17x. Add 18 to both sides. And here we have 103. Divide both sides by 2. We have a negative 17 over 2x plus 103 over 2. So y equals negative 17 over 2x plus 103 over 2. It's always good to double check. So you can do this in your regular graphing calculator as well. Now that we have it in slope-intercept form, we want to confirm our slope-intercept form. So y is negative 17 over 2 times x plus 103 over 2. Okay. And now we want to confirm this. I'm going to zoom out. Again, the connection is very slow. But our points, we used 5, 9 for one of them. And we see that does fall on the line. And the other one, 7 and negative 8. Yes, those points do fall on the line. So this does hit those points. So which of the following describes the graph? We note that this goes up to 10, but there's only 5 lines. So each line represents 2. So when x is 0, y is positive 4. That is true of b. And looks like b only. Because here, when x is 2, y is negative 4. Or sorry, x is 0, y is negative 4. C, x is 0, y is negative 4. D, x is 0, y is 0. So part B is the only one that gets the y-intercept right. We could also check the x-intercept. If we let y equal 0, here x is positive 2. Here we let y equal 0, x is negative 2, which is correct. Here y is 0, x is negative 2. And y is 0, x is 0. So again, B is the only one that gets both intercepts correct. And the linear relation is completely defined by 2 points. Once you have 2 points, you could find the exact equation of the line. So if we have 2 points that work, the whole line has to be correct. So now, 2 lines intersect at the point negative 13 and 61 over 10. One of them is parallel to the equation we have here in slope-intercept form. Which means, now we're given the opportunity to write it in any form. I'm going to take slope point form, because that is the easiest one to write it in. There's our y minus the y coordinate. Now, for the parallel line, here's our slope. And before we have the x, we do x minus our x coordinate, which in this case is x plus 13. Okay, I was trying to highlight and copy inside the box. But there is our parallel line. Our perpendicular line will pass through the same point. It'll just do it with a negative reciprocal of the slope. So we have y minus 61 over 10 equals a negative. Sorry, the original was negative. This has to be positive now. It's a positive 20 over 67. And we still have the x plus 13. All right. So that finishes RF7. Now, RF6, we write this in standard form. That's our AX plus BY equals C. Looking at our X terms, they're both positive. So we're going to have 16x. Looking at our y, we have a negative 17 and a positive 14. That works out to negative 3y. We want our constant on the other side, but here we have two constants. There's a 9 and the 12. We subtract the 9 from both sides, and we end up with 3. So there is our standard form. Slope-intercept form, we have to convert that. So we have 16x minus 3y equals 3. If we have slope-intercept form, that's y equals mx plus b. So let's start by isolating our term with y. So it's going to be a negative 16x plus 3. Divide everything by negative 3. We're going to have 16 over 3x minus 1. So here's our slope-intercept form. Y equals 16 over 3x minus 1. Okay. And then finally, slope point form. It's around that point, negative 13k. So we want to find out what the value is at negative 13. So if we let x equal negative 13 here, we have y equals 16 over 3 times the negative 13 minus 1. Oh, that one did come through. All right, so putting the whole thing over 3, our minus 1 is going to be a minus 3. 16 times 13. Well, 14 squared is 196. And yeah, so 13 times 15 is 14 plus 1 times 14 minus 1. So that's 195 for 13 times 16. Or 13 times 15, we add one more to 195. And we should have a negative 208 for 16 times 13. So if I've done the mental math correctly, our y is negative 211 over 3. So we have a slope point form. So we have y, and then because it was minus 211 over 3, we're now going to have plus 211 over 3. Our slope is 16 over 3. And they gave us 13 as the x. All right. So here we want to convert this equation to slope point form using any point other than the y-intercept. If we let x equal 19, then we'll have a negative 15 plus 16 over 9. So negative 15 plus 16 over 9. Speed things up. Noticing we've added almost 15 minutes and we are on question 9 out of 50. I'm just going to pull up the calculator for the negative 15 plus 16 over 9, which is a negative 119 over 9. So we have y plus 119 over 9 equals negative 15 over 19 x minus 19. That is one possible answer. One of the reasons these are always written responses because there's infinitely many. The only thing we said is don't use the y-intercept because then it's hard to distinguish between slope point form and slope intercept form. Now for standard form, that's a little bit easier. So we have y equals, the original question was negative 15 over 19x. And then plus 16 over 9. multiplying everything by both 9 and 19. So 19 times 9, that'll give us 171y. And negative 15 times 9 is negative 135x, where the 19 just canceled. And then on this one, the 9 will cancel. We have 19 times 16. That is 304. So we should have 135x plus 171y. Make sure the coefficient of x is positive. That will equal 304. We do a quick check for common factors. 135 is divisible by 9 and by 5s. Now, the greatest common divisor of all three of them is 1. So this is the fully reduced form. 135x and 171y is 304. Okay. All right. Moving on to relations and functions 5. The domain of this graph. This one continues past the ends of the graph. So our domain is all real numbers. The range is from -2 all the way up to infinity. And this one, reference numbers. So the domain of our first graph is, again, all real numbers. That's 4. The range is 4 and up. So y greater than or equal to positive 4, that's number 5. Our second graph, the domain is, again, all real numbers. Because we are not divided by 0, we're not taking square roots and negatives, and we don't have any logs in this course at all. The range is positive 4 and down, so that is 7. So here, minimum value in the domain as graphed. This domain starts at -4. Maximum value of the domain is 3. Our range goes from -3 to positive 4. And the next set, it's similar ideas. Minimum value here, we have a -1. Maximum is 2. And in our range, the minimum value is 0. The maximum is 4, even though that's not at the end of the curve. It comes back down, but the highest value it ever has is 4. So here, we are now in relations and functions 4. If the following list of numbers represents a relation, what is the value of c? Well, when x goes up by 1, y goes up by 2. So if x goes up by 2 from 3 to 5, y has to go up by 4. Starting from 9, that's a 13. This one, which graph represents the linear relation y equals x plus 6? That's a slope of 1 and a y-intercept of 6. This one, we have the y-intercept of 6. When x increases by 2, so does y. B has the wrong y-intercept, C has the wrong y-intercept, D has the correct y-intercept, but a negative slope. Now here, one of these is a linear relation, the other one is not. Our first one, x always goes up by 1, y always goes up by 2.5. The second one, x always goes up by 1, but y goes up by 0.25, 0.75, and 1.25. So we got 1 mark for identification. Table 1 is linear. It's because we have a consistent slope between all of our points. Ideally, we want this in complete sentences, but ideally on a test, you're only doing 3 outcomes and not 10. So here, the relation above that represents a linear relation. Well, 1 is curved. 2 and 4 we could graph, but 3 is in our slope-intercept form, which defines linear relations. So we know it's number 3. 2, just in case we had to argue or explain, up by 1, and y goes up by 3. There, up is 2 and up 6. Up by 1, y goes up by 3. So remember, this one looks like it should be a 3x minus 1. That actually does work. Okay. So there's something in the randomizing I need to check there. But 3 is the linear form. Okay. So relation 4 definitely doesn't go up in a linear fashion. I'll have to double check relations 2 and 3 there. Remember, the slope of the line through point Q, that's a horizontal line. Change in x divided, or change in y divided by change in x when the change in y is 0, is 0. R, well, we come down 2 and write 1, 2, 3, 4, 5. So that's a negative 2/5. We can also see it's not horizontal, it's not vertical, and because it's coming down to the right, it's negative. So you could jump to that just purely based on the fact that it's the only finite negative number here. Now, Chin made $120.50 for 7.5 hours of work. His rate of pay is, well, we're asked for the slope if we were to be graphing that. So what is the slope between the points 0, 0 and 7.5, 120.5? That's going to be 120.5 divided by 7.5, or 16.06 repeating dollars per hour. Now the slope of the above graph, we want to represent it as a fraction. Looks like we have a pretty clear y-intercept at 3. And zooming in a little bit, we want to see if we could find any other points that are pretty clear intersections. And I think we have one at 5, 7. So it's up 4. The rise is 4, the run is 5, 4 over 5. Just reset the zoom. Now the slope of this line, if that's a 2, we start at 3. We come down to 1. So our rise is negative 2, and our run is 1, 2, 3, 4. Negative 2 over 4 reduces to negative 1 over 2. Working on relations and functions 2, which is a domain and range, or relations and functions. This one is not a function. At this point, we have 2 points with the same x value. It fails the vertical line test at x equals negative 1. This fails the vertical line test almost everywhere. The circle fails the vertical line test between the right and left extremes. This cubic is fine. Which of these is not a function? Emphasis on not. Well, slope-intercept form, that's a function. Horizontal line is a function. No repeat x values, that's a function. This one, negative 9, has 2 arrows coming out of it. 1 input, 2 outputs. Not a function. Now here, we have to zoom in before we can really tell, but x equals 2 also has 2 arrows coming out of it. So that is not a function because the value when x is 2 is not unique. And what here represents functions? Those will be ones that pass the vertical line test. 1 fails. 2 fails. So anything with either 1 or 2, we immediately know is out. That leaves only C, because 3 and 4 are functions. They pass the vertical line test. Here, A and 4, multiply and simplify. This is the product of perfect squares. So we're going to have x minus 5 times x minus 5. Then minus 5 times minus 5 is positive 25. And the negative 5x appears twice for the negative 10x. Remember, we're not doing x squared minus 5 squared. We're doing x minus 5 times x minus 5. So we have the two negative 10 terms. Now here we are multiplying out. So if we multiply first by the x, we have 2x cubed plus 3x squared minus 5x. Now we multiply by negative 4. And now we can collect our like terms. We have 2x cubed. For our x squared, we have a positive 3 and a negative 8. That's 5x squared. Negative 5 minus 12. And our constant is plus 20. Now, this one, similar approach. 3x cubed plus 5x squared minus 6x minus 6x squared minus 10x plus 12. Now we collect our like terms. 3x cubed plus 5 minus 6 is minus x squared minus 16x plus 12. All right, simplifying this one, we have two x's being multiplied. It's going to be the sum of their exponents. 4 over 7 plus negative 1 over 7 is 3 over 7. Now here we have a 3, or x to the 3 over x to the 8. That's going to give us an x to the 5 in the denominator. There's only one of these that has that. The y, 8 minus 3, is a 5 in the numerator. Now 1 over x to the 6 is the same as x to the negative 6. And then simplifying these. And we have to notice our bottom term is squared. So let's break this one out. 4x squared y to the negative 2. So we have 4x squared, supposed to be squared, y to the negative 2 times x to the 5th y cubed over a negative 2x cubed y squared So multiplying our numerator, we have 4x to the 7 y. 4 times 1 is 4. X squared times x to the 5th is x to the 7. Y to the negative 2 times y to the 3 is y to the 1. And if we multiply negative 2, or take negative 2 and we square it, we get 4. X cubed squared, exponent of an exponent, we multiply together for x to the 6th. Y times y is y squared. For our cancellations, our 4's cancel. All but one of our x's cancel. And all but one of our y's cancel. So part A simplifies to x over y. Part B. So that 1/2 exponent says we take the square root of everything. So this will be a 2x to the negative 1 in the numerator and 3y to the negative 2 in the denominator. That means it's 2y squared over 3x. Now we bring that to the 5. And we have that to the negative 5. So let's do it this way. Put it in brackets. So our first step, we have a 4y to the 4 over 9x squared. And that's to the negative 5 over 2. If we deal with the negative first, we're at 9x squared over 4y to the 4. And that is to the 5 over 2. We deal with that over 2. We deal with our square root. Now we have a 3x over 2y squared to the 5th. So 3 to the 5th is 243. X to the 5th is just x to the 5th. 2 to the 5th is 32. And that'll be y to the 10. So that's our answer for part B. Okay. Now in the home stretch, which of these is irrational? So the square root of 16.00 is 4. The square root of 64 is 8. So it's between B and D. D is tempting. There's no pattern to these digits. There's also not a dot, dot, dot after. But 25 and 16 is 41. 41 is not a perfect square. So here, what are the irrational numbers? 4 of these are irrational. Square root of 169 is 13. Cube root of 27 is 3. 24 is not a perfect square. 7 is not a perfect square, so that 1/2 in the exponent doesn't help us. 4 to the negative 1/2 is 1 over the square root of 4, which is 1/2, which is a rational number, not an irrational. 6 is rational. Pi is irrational. 3 to the negative 8. Well, that's just 1 over 81 squared. So 6,400 plus 160, so 6,561. 1 over 6561 for 8, that's rational. 9, 2 is not a perfect cube. So that is our other irrational number. Now, on a calculator, sometimes not all values can be shown. To which sets of numbers does this belong with these 3 dots? So if a calculator chops it off before you go to the end, this is irrational. It can't be whole. There's non-zero digits after the decimal. Natural would be wholes from 1 up. Integer, again, all 3 of those, A, B, and D, are eliminated by the decimals. And if this were rational, there'd be some kind of repeating pattern or the decimal would terminate, neither of which is applied. So here, estimate the value of this radical to 1 decimal place. Now, a lot of students would look at this and say, okay, 45 is between 36 and 49. Therefore, it's between 6 and 7. That automatically makes it 6.5. It doesn't. So 6.5 squared, if we do that in the calculator, that is 42.25. 6.6 squared is 43.56. 6.7 squared is 44.89. So that's only 0.11 away. 6.8 squared, 46.24. So 6.7 is the closest to 1 decimal place. Now, are these numbers rational or irrational? Pi is a dead giveaway. This terminates, it's rational. 8 is not a perfect square, but 16 is a perfect quartic number. All right, the lowest common multiple of 16 and 12. Well, the greatest common factor is 4, so we can multiply them together and divide by 4. It's 48. So 48 is 12 times 4, and 16 times 3 is 48. So when the cube root of 2000 is a mixed radical, well, 1000 is a perfect cube. So this would be 10 cube root 2. The radicand is what's under the root, so that's just 2. Square root of 1,225. There's nothing on this question that says don't use your calculator, so we can. It's 35. Now the greatest common factor of 84, 210, 336, we could use calculators for assistance or use the Euclidean method or factor it all out. This is 42. If you don't have the proper calculator yet and you don't have one that can calculate GCF and you're pressed for time because the methods by hand do take time, another alternative, take 84 divided by 42. Divide them all by 42. Does it go in? Right? Because 14 times 3 is 42. We could check both. If they're all divisible by 42, well, then that says they're divisible by 42, not 21 of 14. 1,680 is greater than all of them, so that would be the least common multiple. But for the viable options, the ones that are less than any of the numbers, divide all three by each of those and see if it works. That only works in multiple choice, obviously, not written response or numeric response. But it can work until you get the proper calculator. Now, finally, the number 9,621 can undergo prime factorization. So it has two factors. Okay, we can use our calculator for assistance here too. It is an odd number, so it's not going to be divisible by 2. But 9 plus 2 plus 6 plus 1 is 18. 18 is a multiple of 3. Therefore, the whole number is a multiple of 3. So how many 3's do we have? 9,261 divided by 3. Goes in once, twice, 3 times, but only 3 times evenly. After dividing it by 27, which is 3 cubed, we get 343. So our next prime to check, because it's 343 is not a multiple of 5, would be 7. And it is a multiple of 7. 343 divided by 7 is 49, which is 7 squared. There are 3 factors of 7 here. So we're done. You just pop over to my window. I'm going to pause and go grade it, make sure there's no issues. All right, there should be no issues here. We submit. And there we go. That's the 50 out of 50 we're looking for.